Okay, start with the preparation assignment. Number 1, list at least 3 characteristics of the student's t-distribution. I said bell-shaped, symmetrical, and the mean is 0. But they were like, right?
2 other areas I know, like the exact shape depends on degrees of freedom. How many degrees of freedom you have affects the bell shape. And also, there's more area in the tails than a regular standard deviation would have. So.
Oh, that's right. That's right. I was noticing the P scores were larger.
Yeah.
I did notice that. That makes sense. Number 2, how many degrees of freedom generally does the t-distribution have when it is used for inference for a single mean? And the answer was just the formula for degrees of freedom, which was n minus 1.
Yeah, that's what I got.
Sample set. Number 3, what is the formula for the one sample t confidence interval? Confidence interval for u and sigma is unknown.
Basically, you just substitute t in for z and s in for u. It's like no difference.
Yeah, that's it.
So you like, yeah.
That's x bar plus and minus that.
Yeah.
Number 4, what are at least 2 differences between the one sample t confidence interval and the one sample z confidence interval? We covered in lesson 10. This one confused me at first.
Yeah, same here.
But after consulting the textbook and the answer key, the t distribution uses degrees of freedom and sigma is not known. Like, it made sense after I realized what they were asking.
Yeah.
Oh, I felt on that one.
Definitely.
It's like, what do they want me to say here? Okay, number 5. When conducting a hypothesis test for a single mean with sigma unknown, what is the formula used to compute the test statistic? It's t for z, or no, it's just the mean minus x bar over.
You mean x bar minus the mean?
Oh, that's what I meant. I wrote it wrong. And this one confused me too, because I didn't think we were supposed to know the mean.
Like, yeah, I think the mean, it just comes from the null hypothesis. So, yeah, so technically we would know the mean because it's like the null hypothesis value and then our mean pretty much over our sample deviation.
It's the mean we're testing.
Yeah.
Not one we're sure of.
Exactly.
Okay, that makes sense. And it's over s over the square root of n.
Yeah.
Just substitute s for the population standard deviation. 6, what are the requirements that need to be met to conduct a hypothesis test for a single mean when sigma is unknown? I said x bar is normally distributed and the sample mean is random. I mean, the sample is taken randomly. Okay.
Oh, question for you before we go too much further, because I know there's a part where it says you're supposed to do a graph with but you can't use the normal applet. Is there a place to go get the other applet?
Oh, like the part where it wants you to color?
Yeah.
I don't know. I didn't find another applet.
Yeah, we'll have to ask her. because that might actually come in handy if we have to like use that for a test or something.
Yeah. Yeah, on that one I didn't find a place for a graph. I just like described it.
Yeah.
I just said you're gonna draw a bell-shaped curve and shade the tails.
Pretty much.
That would be nice though to have an actual applet. I don't know why they couldn't if they could make the normal probability one.
Yeah, it's probably just somewhere else, and I just don't know where to find it. I was looking all over in the book to see is there like another applet or something. Maybe it'll be given in the quiz or something.
Maybe.
Anyway, sorry.
Anyways, number 7 is just like number 6.
Yep.
Okay, it's the same question. So anyway, it lays out this real estate study from a couple chapters ago. Null hypothesis is 47. Is that means 47? He takes her sample 15 or the ages. I typed this straight into the new magic spreadsheet.
Yeah.
Okay. With the data above, this is number 8, calculate the margin of error and create a 95% confidence interval to estimate the mean age of all clients who buy an investment property. Input the numbers you computed in number 7. I didn't compute any numbers in number 7. Of part 1, there was no 7 in part 1, into the confidence interval formula. Show your work below. T-score for a 95% confidence interval from the T-distribution with 14 degrees of freedom is 2.1448, which is not the T-score that the spreadsheet gave me, by the way.
Yeah, because
go ahead.
I was say the T-score. Well, wait, no, I might have changed something a little bit. Yeah, what was your T-score on the sheet that you got?
It was negative 0.117.
Yeah, because I'm looking at mine, and that's the same one I have, and like,
yeah,
I don't know.
It gave us the right intervals.
Yeah.
But yeah, I don't know what, I could not figure out what this bogus T-score was that they gave us.
Yeah.
They give another one later too.
Yeah. So this is where it gets weird. So then I went and tried to plug in the values, and so I actually plugged in the T value that was provided. So if you take the X bar value, which is this, what is that, not the sample mean, because it's not the 47, it's the 46.733. And then you do the math and you substitute the values in, it comes out as a decimal, but it's only like a couple hundredths off. It's weird. Like, that's where I was confused. If you're trying to solve this by hand, I have no idea how we can do this without some rounding, and then we're getting like the computer solutions, but then we're supposed to have the same solutions by hand. So I don't get it, because we're giving rounded numbers.
Yeah.
So there's like no way to do that.
There's no way you'd be able to do it by hand.
Well, so let's see, 46.733. Just gonna do this minus, and then the given T-score, which was 2.1448, times, which was our S was 8.827, divided by the square root of 14.
15.
Well, no, isn't it the square root of 14 because it's n equals n minus 1?
Well, that's the degrees of freedom, but I thought we still used isn't it still the square root of a?
Let me see if it's square root of 15, if that changes anything.
Oh, I got it with square root of 15. The same.
Oh, okay, so that was my problem. I just need to make that 15. Okay,
well, and when I say I got it, I mean I got what the spreadsheet got, not what this question says.
Yeah, no, I got the but I got the solution, was the 41.845.
Yeah. I got that too. And the t-score is negative 0.117.
Yeah.
Not.
But the thing says 14 degrees of freedom.
Right. You just don't use that in the calculation.
Okay.
You still use n.
Okay, well that makes me happy that we can at least figure it out.
Yeah. Do you know what this 2.1448 is supposed to mean? It says it's, wait, is that 2 times our, no, it's not.
The t distribution with 14 degrees of freedom is 2.1. I think that's where it's coming from, like the applet or something, where it's the confidence interval from the t distribution with 14 degrees of freedom is 2.1448. So we're substituting that in for the t value.
Well, it says the t-score is that. The t-score for a 95% confidence interval from the t distribution with 14 degrees freedom is that. But that's not the t-score that we got.
No, our t-score is different.
And it's right. Ours is right.
Yeah.
I'm just totally lost by that number.
Mm-hmm. I wonder if that's like I wonder if that's like the shaded region though, or something. Of like on the applet or something. You know what I mean?
Oh yeah.
I have no idea because I just don't know where that 2.1448 is coming from.
I have no idea either. I just ignored them. The same thing on number 9, but it's 2.9768. No idea what that is.
Yeah. Okay. Well, that makes me happy though. At least it's just under the square root of 15, not the. That makes me happy.
So yeah, my confidence interval was 41.845 to 51.622.
Yep, that's what I got.
And then on the next one is the same thing, 99% confidence. I got 39.948 to 53.518.
Yep. Hopefully we just don't have to find that whatever that t-score, the t-distribution, the freedom is, whatever that is.
Yeah, whatever that thing is.
Wait a minute. What was the first one?
Which, the t-score?
Yeah, the t was like 2.1448 or something.
It was.
Yeah. Yeah, that's weird because I have no idea where that number's coming from. Weird.
Huh. Very weird. Okay. Maybe Sister Lemon will watch this video and come to our rescue.
Yeah, that would be great.
Did you see that email she just sent out like 10 minutes ago?
No, what did she send?
She just said, like, I've been watching a lot of videos and people don't know the difference between, like, they don't know how to find confidence intervals. They don't understand that it's just double the margin of error. Like, it was all stuff that we get, but it's just a nice little help.
So that means the confidence interval is. I still know where that is. That the confidence interval? Is that the margin of error doubled?
Yeah. So it's just to get your confidence interval, you add the margin of error to the mean, and you subtract it from the mean. And those two numbers are your confidence intervals.
So if I add 40, is it 7 or 46.73?
46.73.
So I add that plus the standard error. Oh no! That's just saying. That's just the equation. It's
just the equation.
That's just what we did. Okay, yeah, I get that part.
stuff we know.
Yeah, that's all stuff we know. We can figure that out. It's just the random number with the 14 degrees of freedom.
Yeah. No, she didn't help us on that yet.
Okay.
It just made me feel good that she sent out a help email and it was stuff we already knew.
Yeah, that's good.
Gave me some confidence.
Yes.
Okay, number 10 were the same answers.
Yeah.
That's 9. Number 11, how does the margin of error of the 95% confidence interval compare to the 99% interval? And I said the 95% interval was smaller.
How did you determine that?
Well, this is the one that doesn't make any sense, but if you just look at the confidence intervals, the one we got with the 95% confidence level is smaller. It's a smaller gap.
Oh,
It's always like
that. Sorry, go ahead.
Remember, it doesn't make any sense, but the higher your confidence gets, the wider your interval gets. Instead of, logically it should be the other way around, but it's not.
I remember that. I remember that, yep. So the 95% would be smaller than the 99%.
Yes. Don't ask me why, but it is. Okay, number 12. Rather than estimating the age of his clients that buy investment properties, the realtor agent would like to test the claim that the age of his clients is different than the national average age of 47. Use the alpha 0.05 as your level of significance. Follow the following sequence of steps. Fill in your answers at each step and show all your work. A, state the null and alternative hypothesis. Null 47, alternative not 47. I don't know how to make the not equal sign in Word.
You have to insert a symbol.
Oh. Okay. Not worth it for this assignment. B, compute the test statistic. First compute it using the formula and showing your work below, then check the statistic by inputting the data into the software. I got the same answer both times.
Okay. So that one, is that one still where you'd use like a square root 15?
Yes.
Okay.
Yeah, it's the exact same formula as above.
Cool.
Degrees of freedom, though, is 14.
Yes.
Sketch the distribution and shade the area which represents the p-value. I didn't do that. Did either of you guys draw? Me neither. But it's like a normal curve with both the tails shaded.
Yeah.
Right. And the spreadsheet told me the p-value was 0.909.
Yep, that's what I got.
Or 908.5.
Yeah, 909.
My decision was to not reject the null.
Yeah, so he failed to reject the null.
Yes. Because the p-value was larger than the alpha.
Yep. Was not statistically significant.
Oh, nice verbiage.
All right. And then, yeah, the last one is basically, it's like, hey, we can't prove it. And after I consulted the guide, basically we have insufficient evidence to conclude that is different than natural average. And that's because that we failed to reject the null hypothesis. Yeah, that's pretty much it.
Nice.
All right, we ready to do this quiz?
Yes. Sharing it. Whatever it is. Okay.
Hopefully, we don't have to calculate that whatever number, because
I know. I don't even. It would.
Screwed.
For me to know that's what it wanted, it would literally have to say the whatever number.
Yeah.
Because if it says t-value, that's not what I'm going to get.
Exactly.
Whatever that thing is.
This is just linked to the normal probability applet. What the? Well, that's no good because it's not normal.
Where? Oh, I don't even have a link. Oh, there it is. Yeah, that's weird.
Because if you look at the picture on the other one, it's not the same applet. It's a different one.
Yeah. Yeah, it's totally different. And it'll be one where you have to like input the sample size, right?
Yeah.
Or the degrees of freedom because it changes it.
Exactly.
Okay.
Hopefully we don't need an applet. So.
Yeah. We have the spreadsheet at least. Number 3. In previous lessons, we had assumed the population standard deviation sigma was known. In this lesson, we are making a different assumption about sigma. What has changed?
Sigma is unknown. Right?
Yep. That's what I think. For the next 2 questions, let the null and alternative hypotheses be null is u equals 8 and alternative is u is greater than 8. Assume the population standard deviation is not known. Becker collects a sample size of 9 and computes x bar to be 11 and the sample standard deviation to be 6. Is sigma known?
No.
Good question. What's the value of t? Okay. So now it's making this do it by hand. One.
Do we have to round anything? Oh. Did you guys get your solutions yet?
I got 0.5. What'd you guys get?
I got 1.5.
I got 1.5.
Uh-oh. I did, I subtracted, oh, okay. I got the sample and the X bar switched around.
Oh, oops.
So it should be 11 minus 8 divided by 6 over the square root of 9.
Yep.
Which is
basically 3 over 2 or 1.5.
Yeah. 0.15?
1.5.
Okay, that's better. Just doing this one more time.
Oh, we can't copy this.
Finally got it. You can't copy it? Oh no.
Oh man. Okay.
I'll type it for us. It's worth it to me. 98, 99.6, 97.8, 97.6, 98.7, 98.4, 98.9, 97.1, 99.2, 97.4, 99.1, 96.9. These are like, I'm thinking of radio stations.
Nice.
Okay. That is lame. How they make it so you can't copy it. That's really funny.
So what was that one? 98.2. Where'd you get that one at?
X bar.
Mean?
It's just the sample mean.
And what'd you get? 98 point what?
98.28. So
That's
if we got different ones, I need to check my numbers.
Because I plugged my numbers in and I got 98.24.
Uh-oh. I plugged mine in too. Let's check. Let's go through and check our numbers.
Okay.
So from the top, I have 98,
98,
99.6,
99.6,
97.8,
97.8,
97.6,
97.6,
98.7,
98.7.
98.4,
I have 98.4,
98.9,
98.9,
97.1,
97.1,
99.2,
99.2,
97.4,
97.4,
99.1,
99.1 as well,
96.9,
96.9,
98.8,
98.8.
Well, you guys,
99.9.
you guys dived right into it.
99.9.
Hey, Philip.
Oh, what up? I maybe just slept through that first alarm again. Just back to back. I'm just crushing it.
That's okay. We're just double checking our numbers. So we did 99.9, right?
Yep, 99.9.
Okay, 96.8,
96.8,
97 even,
yep, 97,
98.7,
98.7.
97.6,
Whoa, oh, 97.6. Okay. What was the next
98, 98.7,
one? 98.7, okay.
98.2 is the last one.
98.2.
Were there any errors?
I had one where I repeated a 98.7 twice. So then for my mean now, I have 98.22.
What? I
Well,
still have 98.28.
What are your settings? Is your interval confidence level set to 0.95?
Yeah.
Okay, how about your null
That shouldn't
hypothesis?
affect my
Mine's
mean.
at 0.
Null hypothesis.
Yeah.
Yeah, now mine's a 0 too, but at least this won't affect the mean.
How about the type of test? Did you put like not equal to, greater than? No, it's not going to affect the mean though.
Yeah, mine's on not equal to right now. What the heck? Yeah, I have it. Here, I'll share this.
Let me see yours. I hate that we just can't copy the data. That makes me mad.
I know.
Like, ugh.
Are you guys on number 6?
I think so, yeah.
Okay, inspect my spreadsheet here. So we checked all these values over here, and it calculates the mean right here, 98.28. And then I also just typed the formula myself in here.
Okay, let me try that. All right, just let me read down my list again really quick, and tell me if there's a wrong number.
You were right. You were right. I had it wrong.
Oh, what was that?
So when I calculated the mean myself last time, I only had like the first 15 cells selected because that's how many were in the last problem.
Oh.
But this is
You had
20
something left over.
I was only doing the average for the first 15 numbers.
Okay.
My bad.
98.22. Are you putting the 0?
Oh, I don't know. Does it tell us to?
It says 3 decimals. For hold on. I'm one behind. I got everything else. I gotta go back and do the fourth one. No, the fifth one.
So, did you get the have you gotten the number 7 yet?
Well, I did, but I'm just realizing I need to recalculate that as well to include all the data. So I got 0.922.
That's what I got.
After further inspection. Yeah, that was a bummer. It's a bad formula is what it is.
Bad formula.
All right, for 7, you got 9.22.
Yep.
Yes. What is the t-score? My t-score is, oh, well, what's our null hypothesis? It's 98.6 is the null.
Mm-hmm.
And it didn't mention what our confidence level is, did it?
No, because we're just testing. Right now, we're just testing the null hypothesis, so it doesn't have a confidence level. It's just got to be within a level of significance.
Okay, so this will change my number. Oh, yeah, doesn't change it. My t is negative 1.843.
A second. So, sorry, I was something. So what is the t-score? What did we put for the t-score?
I got negative 1.843.
Negative 1.483.
843 actually.
Oh, 843.
Did you get 483?
No, I haven't calculated that one yet. Did you just do the Okay, so then what was our was 98.6. Okay. I'll hurry and calculate it really quick and I'll tell you.
I'll do it by hand too for practice.
So you got 8.220 minus mean, which was 6 divided by our sample, which was divided by square root of how many of them were there? There was 20.
Yeah, there were 20.
Okay, divided by, so be divided by the square root of 20, right?
Yes.
Yep, so I got my answer, I got negative 1.843 by hand.
Cool.
And how did you get that on the computer?
I put it in my spreadsheet.
Looks like where I'm trying to see where the negative is showing up. Can you show me where on your spreadsheet that shows up?
Yeah.
Whoa, how's your T that? Because my T is like way different than yours on my little spreadsheet.
Is your null 98.6 up here?
Oh, that would probably help. 98.6. Oh, there we go. Helps to just put it in there correctly.
I had one the other day and I was looking at it and it had like a t-score of like 109 or something. And I was like, shoot, what'd I do?
Oh,
and that's what I did. I had the null hypothesis wrong.
Nice.
So the last problem, I'm like, oh, okay, all right.
Yeah, when the t-score is over 100, you're definitely going to reject the null, right?
Yeah.
Like, huh. I think the null might be a reject on this one, guys.
100 standard deviations away? Okay.
All right, so impossible? All right, fantastic. Yeah, check.
We're assuming it's less than, so our symbol needs to change to the less than.
So what?
Because the type of test, aren't we testing to make sure? Oh no, I guess it'd be greater than.
I think it's
That's
greater than.
going to change the p-value, which one we choose.
Whoa, why is it a different number? I thought the tails would each be the same.
We're saying that the hypothesis is going to be the mean is actually less than 98.6. So on our table, we need to change the type of test to make it less than.
Okay, when I do that, I have 0.040.
Yep, that's what I got.
You don't round that last digit.
Oh. Yeah, no.
Okay, just wanted to make sure. I saw there was something else, and I have not gone through the painstaking process that you guys did to put the data in, and I don't want to because I saw the errors you guys had, and I think you would just love for me to give you more conflicting data. Right?
Yeah, it's ours.
Yeah. I can't wait to do this on an actual quiz or test. That's going to be the best.
All right.
I would say so. Based off of that, where you're 0.04, I mean, are we using fail or reject? I mean,
we should be able to reject the null hypothesis because it's less than it. Because we were testing to see if it actually was less than. The p-score is lower than the level of significance. So I think that means we would reject the null hypothesis.
Yep, let's reject it.
Oh my gosh.
No.
I know. Come on, Mike. Won't you let me copy?
At least there's decimals. I mean, at least there's no decimals.
It's all whole numbers.
Okay. So do you want to read them to me really quick? I'll plug them in, then I'll read them to you so you can plug them in? Or,
Yes.
Okay. So what's number 1?
From the top. 59.
Okay.
14.
Okay.
37.
Okay.
62.
Okay.
68.
Okay.
2.
Okay.
15.
Okay.
9.
All right.
157.
157. Okay.
157. 27.
Okay.
37.
Okay.
2.
All right.
55.
Okay.
86.
Okay.
14.
Okay.
4.
Okay.
40.
Okay.
36.
Okay.
47.
Okay.
9.
All right.
61. And that's it.
Okay. So I had 21 values that I put in there.
Okay.
Okay. Ready?
I'm ready.
59.
Okay.
14.
Okay.
37.
Okay.
62.
Okay.
68.
Okay.
2.
Okay.
15. 9.
Okay.
157.
Okay.
27.
Okay.
37.
Okay.
2.
Okay.
55.
Okay.
86.
Okay.
14.
Okay.
4.
Okay.
40.
Okay.
36.
Okay.
47.
Okay.
9.
Okay.
61.
21. That's 21 values for me too.
Okay. Cool. So
What's your mean?
let's see. What's our null hypothesis is 40.
Mm-hmm.
And we're doing it not equal to. Okay. Did you get a mean of 40.048?
Yes.
Sure did.
Sweet. Okay. Good. So the p-value, I got 0.995.
For t-value?
Or for the
We're trying
p-value.
Oh yeah.
Well,
Yeah,
are
p-value
we
that we're
trying to
solving for.
find if it's greater or smaller?
We're just solving for the p-value itself right now. Question 5. I got 0.995.
You mean t?
No, p as in Papa. That's what question 11 asks for, is the p-value.
So this one,
Yes, I got 0.995.
okay, perfect. This one, because our value of our level of significance is 0.01, this one would then fail to reject the null hypothesis, or yeah, it'd fail to reject the null hypothesis.
Yeah, like by a long shot.
Yeah.
By 1 billion. Should do this. That one.
Now we're gonna make it less than 40. P-value decreased.
Decreased. Still a reject though.
Yeah. So then we still do fail to reject. Okay.
Yeah, failed to reject. Okay.
Because the significance is still 0.01, right?
Yeah, 0.01 is right.
Okay. Okay.
Be careful on the next two. You only round to 1 decimal.
Oh, okay. Thanks. So that would be 40 minus.
Is this what you guys are getting? As far as your maths.
So did you do 40.048 minus the t value, which is 0.006 times the standard deviation, which would be 36.356 divided by the square root of would that be 21, or would that be, yeah, it would be 21.
You lost me.
Yeah, I did copy and paste on that one, my friend.
So what number did you get?
23.5 for the lower and 56.6 for the upper.
Yeah, I got the lower. I got a different one than you.
Sounds like you did it by hand.
I did.
Oh,
I
it's in your spreadsheet too.
definitely stole your old spreadsheet.
Oh, okay, okay. Yeah, then duh, it would just be I said something wrong by hand.
You're working too hard.
Yeah.
Yeah, too hard. It's already there. 23.49. But it's only 23.5, right?
23.5 because we round to 1 decimal.
Okay.
I got the same things as you, Philip.
Okay.
Okay, and the other one was 56.6.
Yes.
Yeah. Hey, can someone do me a solid here? 5. I didn't want to do any work. What's number 5?
1.5.
I knew it wasn't going to be hard. I just, oh man, I didn't have you guys to walk me through it, to coach me. I did this last night, this assignment last night at like 2 o'clock. I made all the wrong choices to play Overwatch instead of do the homework. And then my buddy went to bed and I was like, okay, now I'll do my homework. And I was like, no, I made all the mistakes. I did it anyway, but it sucked. But yeah, anyway, okay, that's everything. You got all of it?
That's everything, and we got 100%, baby.
You did?
Yep.
Thanks for being the guinea pig.
Okay, I'm gonna go now and see if I got 100%. 23%. I did so good. I actually did miss one. Which one did I miss? Oh, number 7. What did you put for number 7?
67.922.
I did 9.22. Son of a mother. Oh man.
9.22.
I'm so good at my life. Okay, let's just go again real quick. Let's just another time around the block. Oh, I should have maybe copied all my other work so I didn't have to do it again.
Oh, I missed one too.
Which one did you miss?
Oh,
Failed to reject on that one.
number
I
4.
mean, obviously, you know that now, but
Just marked the wrong one.
Yeah.
Well, that sucks.
1.5.
Okay, is it
Alright, well,
is it just
I
me,
think
or
I'm
do you
gonna
guys
take
like go
off.
immediately after we do these group quizzes and then
No worries, Matt. Sounds good. Thanks for coming, man. Thanks for coming lots longer than I did.
see
Yeah,
that?
see ya.
See ya.
Is it just me, or does like do you guys go immediately after this? One thing I found is like immediately on the homework quizzes, I'll go and I'll do those like right after this quiz.
Oh no.
Yeah.
I wait till 10 o'clock on Saturday night and I hop on. I'm like, let's do some quizzes, yo. And then I just
Oh,
throw
it must be
down,
so
throw
hard.
down. Oh man, it makes it really interesting because I'm like, okay, how well do I really know this? Yeah,
I do them right
it may
away.
not be the best. I don't blame you. Right, meow. I'm actually going to today because I got plans with the old wifey on Saturday.
Yeah.
So I gotta try and like get everything out of the way by then. Oh, can a brother? Oh, you just kept your one up. You're such a freaking.
This is how you are supposed to do this, Philip.
You
wanna know
just
what
leave it
usually-
up and do the next one and makes it
You-
way easier.
You want to know what usually happens? I memorize the whole thing. Usually, if I've gone through the whole thing and done all the work, I can actually remember all of the answers from the last time I did it.
Wow.
Yeah. I mean, that's a big old brag, but honestly, that's what I do. I'm just like, nope, I remember.
You should
But I
see me
didn't
on a
do the
quiz
work for
when I
these
get like
first.
4 attempts.
I didn't do the work for these first ones though, so I don't have it. I'm gonna put the point before the 9 on this one, and just see how it goes.
Yeah, good idea.
I thought so. Oh man, I'll be honest. I saw that clock this morning and I was like, son of a mother, if I've missed the whole thing twice.
If they didn't record again, I'm gonna kill them.
Yeah,
Oh,
sorry
no.
we didn't record last 2 times.
Hey, on 10 we did. Oh man, wait, what? I missed something. 1.84.
10.
What was our p-value? Sorry, what was 9's p? Okay, I need 9 and 10. I'm crushing life.
9
0.04.
was 0.04,
And reject. Okay,
and then 10 was reject.
I'm gonna reject everything. Oh man, we did fail to reject, decrease, fail to reject. I missed I missed something again. Oh, I missed 11. 0.995. That's what I thought. Okay. 0.995. And then I got 14, 15. Oh, lower interval, that's the 23.5. And then you have the 56.6. Is that right?
Yes.
Oh, Bruce, question for you.
Yeah.
So to find the margin of error, because that was the only other thing I couldn't compute, is that just the margin of error? Is that just the mean plus the standard deviation, or how do we find the margin of error?
The mean plus the. Oh. Well, do you know the confidence interval?
The confidence interval would be, yeah, that would just the 2 points, right?
Yeah. If you have the confidence
Lower bound,
interval.
your upper bound.
Your margin of error is your what is it? Your t times our calculated standard deviation divided by the square root of the number. That's the margin of error. And
Oh,
then
it's
plus
the-
or minus.
Oh, okay.
Or the
The margin of error.
z-score over, z-score times standard deviation divided by the
Oh,
square
yeah,
root
no,
of the
because you're just
number.
not doing the plus or minus, but just your margin of error. It's either
Yeah,
adding the margin of
it's-
error or subtracting it.
Yeah, so it's your x plus or minus the margin of error, which is the calculations that we're doing.
Yeah, okay. Yeah, then I know how to do that. Okay, because I couldn't remember. I was
Yeah.
like, I can't remember how to do that.
Like, hold
Okay.
on, guys. Hold on. Oh my gosh.
Did you miss one again?
Yeah, I missed number 8 because I hit the comma instead of the period. I am loving life. All right, well, that's it. Thanks for playing, everyone. Dang it. Alrighty, sweet.
I'm going to stop recording now.
Yeah.